Good morning, everyone. Myself, Mishivardhan B. My roll number is 254G1804H1. I am from 2nd BTech ECE. Today, I will discussing about the subject environmental science. Topic name is thermal pollution. Topic name thermal pollution. Introduction to thermal pollution. Thermal pollution refers to increase in water temperature due to human activities. It primarily affects aquatic ecosystems and the organisms living within them. Understanding thermal population is essential for environmental protection and water resource management. Definition of thermal population. Thermal population occurs when heat is added to water bodies, raising their temperature. It often results from industrial processes, power plants, and urban runoff. Elevated water temperatures can disrupt natural aquatic habitats and processes. Common sources of thermal pollution. Power plants use water as a coolant and discharge heated water back into water bodies. Industrial facilities may release hot wastewater into rivers and lakes. Urban runoff from heated surface such as roads and rooftops also contributes to thermal pollution. How thermal pollution occurs. Water is extracted from natural sources and heated during industrial or cooling processes. The heated water is the discharged, raising the temperature of the receiving water body. This process can happen rapidly, causing sudden temperature spikes in aquatic environments. Effects of aquatic life. Oxygen levels. Warm water holds less dissolved oxygen, which is vital for aquatic organisms. Reduced oxygen levels can lead to hypoxic, harming fish and other aquatic species. This decrease in oxygen can cause fish kills and reduce biodiversity. Effects on aquatic life, reproduction, and growth. Elevated temperature can disrupt breeding cycles of aquatic species. Many organisms experience stress or die when exposed to higher temperatures. Thermal pollution can also alter the growth rates and survival of juvenile aquatic life. Effects on ecosystem balance. Changes in water and temperature can favor some species over others, disrupting ecosystems. Predators and prey may become mismatched due to temperature induced behavioral changes. Overall, thermal pollution can lead to a decline in ecosystem stability and diversity. Impact on water quality and chemical properties. Increased temperature accelerates chemical reactions affecting water chemistry. It can increase the toxicity of certain pollutants, harming aquatic organisms. Thermal pollution can also cause the release of nutrients that promote algal blooms. Human health and economic impacts. Decline in fish populations due to thermal population affect commercial and recreational fishing. Thermal pollution can impact water quality for human consumption and industrial use. The costs of mitigating thermal pollution and restoring affected ecosystems can be substantial. Methods of detecting thermal pollution. Temperature sensors and data loggers are commonly used for monitoring water temperature. Remote sensing technology help access thermal pollution over large areas. Regular sampling and analysis can identify source and impact of thermal pollution. Prevention and control measures. Using cooling towers can reduce thermal discharge from industrial plants. Implementing regulations on permissible temperature increases helps control thermal pollution. Creating buffer zones and vegetative cover around water bodies can mitigate heat absorption. Role of policy and legislation. Environmental laws often set limits on thermal discharge to protect aquatic ecosystem. Policies can incentivize industries to adopt cleaner cooling technologies. Effective enforcement on regulation. Regular sampling and analysis can identify source and impacts of thermal population. Methods of detecting thermal population. Temperature sensors and data loggers are commonly used for monitoring water temperature. Remote sensing technology helps access thermal over large areas. Effective enforcement of regulations is crucial for minimizing thermal pollution impacts. Case study of thermal pollution. The cooling water discharged from the Chernobyl nuclear power plant caused significant ecological changes. The Hauksau River experienced thermal population from multiple industrial resources, affecting fish populations. Successful mitigation projects like cooling ponds have restored thermal balance in some areas. Future challenges and research directions. Climate changes may exacerbate thermal pollution due to higher ambient temperatures. Developing more efficient cooling technologies can help reduce thermal discharges. Ongoing research aims to better understand thermal pollution's ecological impacts and mitigation strategies. Conclusion and summary. Thermal pollution significantly affects aquatic ecosystem and human economics. Preventive measures and policies are vital for managing thermal discharges. Continued research and technological innovation are essential for addressing future challenges. Thank you.